Have you ever wondered why a car stops when you apply brakes? Or why a ball keeps rolling on a smooth surface until it hits something? Or why a book stays on a table unless you push it or pull it? These are some examples of how objects behave when they are in different states of motion or rest. And the answer to these questions lies in the first law of motion given by one of the greatest scientists of all time, Sir Isaac Newton. Newton's first law of motion states that an object at rest will remain at rest and an object in motion will remain in uniform motion unless acted upon by some external unbalanced force. An unbalanced force is, as the name suggests, an unequal force applied on an object, whereas a balanced force is forces applied on an object that are equal and opposite in direction. The first part that states that an object will remain at rest seems to make sense since motionless objects typically don't just start moving. But the second part, which states that an object will remain in uniform motion unless acted upon by external force, contradicts much of our everyday experience. When you throw a ball, it doesn't keep moving forever. It eventually stops. But where is the force that stops the ball or changes its state of motion? Our planet is a puzzle of forces. When we move, there's this sneaky thing called friction that tries to slow us down. Think of it like walking through sticky mud. It's tough. So, when we throw that ball, it's not that it wants to stop, it's just these forces like friction playing tricks on it. So in conclusion, all these forces act as an unbalanced force that is required to change the state of motion. There is an important word in Newton's first law of motion, which is uniform motion. What does it mean that a body will move in uniform motion? It means that its speed or direction will not change without external force. Without force, there is no acceleration or deceleration. For example, you need the engine to keep applying force to accelerate, that is, increase the speed of your car. Or you need brakes to decelerate, that is, decrease the speed of your car. In essence, Newton's first law teaches us how forces affect an object's motion. This understanding sets the stage for exploring our next exciting topic, inertia. Newton's first law of motion is also called the law of inertia. Inertia is the tendency of a body to oppose any change in its state of rest or uniform motion. The more inertia a body has, the more difficult it is to change its state of motion. Let's understand this in detail. There are three types of inertia: inertia of rest, inertia of motion, and inertia of direction. Let us learn about each one of them in detail. The inertia of rest is the tendency of a body to remain at rest unless an external force acts on it. For example, when a branch of a tree is shaken vigorously, ripe fruits get detached and fall. This is because the branch comes in motion, but the fruits at rest tend to remain at rest due to inertia of rest and get detached. After the fruits get detached, gravity plays its role in making the fruits fall. Another example of inertia of rest is when we are standing in a stationary bus and the driver starts the bus suddenly. We get thrown backward with a jerk. This is because our feet are in contact with the floor of the bus and move along with it, while the upper part of our body remains at rest due to the inertia of rest. This creates a backward force on our bodies. Now, the inertia of motion is the tendency of a body to remain in uniform motion unless an external force acts on it. For example, when we switch off a fan, it continues to rotate for a while due to the inertia of motion. This is because the fan has inertia of motion and tends to maintain its speed and direction of rotation. Another example of this is when a moving bus suddenly stops, people inside might feel pushed forward. This happens because their bodies want to keep moving even when the bus stops. So, the bottom part of their body that's touching the bus slows down, but the upper part keeps moving forward for a moment before everything stops together. The inertia of direction is the tendency of a body to maintain its direction of motion unless an external force acts on it. For example, when a car takes a sharp turn, the passengers sitting in the car feel a sideways push. This is because the passengers have inertia of direction and tend to move along a straight line. To make them move along a curved path, a force is required. The friction between the seats and the passengers provides this force. Another example of inertia of direction is what happens when a stone tied to a string is whirled around in a circle. The stone has inertia of direction and tends to move along a straight line. To make it move in a circular path, a force is required. The tension in the string provides this force. What happens when the string is cut? The stone flies off tangentially due to the inertia of direction. The stone no longer has any force acting on it to change its direction of motion. Now let's imagine you have two tables in front of you, one small and one large. Now, think about this. If we gave both tables the same push, which one do you think would be harder to move? Take a moment to guess. Let's find out. When we push the small table and then the big table with the same force, something interesting happens. The big table doesn't budge easily, does it? It's almost like it's saying, "Nope, I'm not moving." Why do you think that is? Well, it's because the big table has more stuff in it, more mass. And here's the secret: the more stuff or mass something has, the more it doesn't want to change its movement. And what do we call when something doesn't want to change? We call this inertia. So, here's the magical rule: the heavier something is, the more inertia it has. That's it. So the next time your bus suddenly stops and you fall over, I want you to remember Newton and his first law of motion. We hope that you have understood the concept of Newton's first law of motion. Now, here's a secret on how you can study effectively with the EduRev app. You can learn with chapter notes, watch video lectures, and solve NCERT-based MCQ tests of this chapter on EduRev. And that's not all. You also get amazing courses for Class 9 and much more for your Class 9 preparation. Thank you.